welcome to our next lecture on pre-calculus. Today we are going to talk about expanding a logarithmic expression. Several type. You see I'm writing example of type 1, another example of type 1. This one your text calls it type 2, and something perhaps a bit more complicated, type 3. They all follow the same format, so let me explain all three of them at the same time so we save a bit of time here. So what is the general idea? General idea is to combine the rules of logarithms we had last time. You remember we had logarithm of m times n in base b was logarithm of m in base b plus logarithm of n in base b. If you had the ratio, it just turns into subtraction. Logarithm of numerator minus the logarithm of denominator. If you had the power, that power becomes a multiple. So if you combine all of these things, what can we write? Here, let me combine it. Say logarithm of a to power of little a, b to power of little b, over c to power of little c, d to power of little d. All of this, I'm running out of letters. Let's call this one k. Well, first we separate numerator from denominator, so it's going to be logarithm of a to power of a, b to power of b, minus logarithm of c to power of c, d to power of d. Sometimes you see the text does not use any base for the logarithm. We said previously that means base 10, and that just makes our writing less cluttered, but the rules are available for any base. It doesn't have to be base 10 or e or any particular one. All of them work. So I'm writing some base b here, base k here, whatever the base might be. Okay, next step, so we applied the ratio. Next we apply the multiplication that we have here. So multiplication is this rule, so I can write it as the logarithm of a to power of a plus logarithm of b to power of b minus all of this. Let me put it in the parentheses, logarithm of c to power of c and logarithm of d to power of d. Next we can apply this power rule here, which tells us that the exponent comes in front. So to simplify, it becomes little a logarithm of a plus b logarithm of b. Let me take the minus inside, so c logarithm of c, and this minus comes in front of this as well, logarithm of capital D. These are base k, all of them. So let's do it in one single sweep here. See, the exponents come in front, the items in numerator are added, the item in denominator are subtracted. So that's a, if you wish to call it, a combo rule. Combo rule, it's just we combined all of these rules that we had in a single example and then we are going to apply it. So let me rewrite this thing. We have logarithm of so you get the gist of the expression that if we were doing something similar to this, it makes sense to apply this rule and be quick. So let's go ahead. The first case, yz9 for logarithm of yz9. So when nothing is written, we said when nothing is written, this means logarithm base 10. That is just to save writing and reduce clutter. So let's practice again. First, multiplication. So logarithm of y plus logarithm of z to power of 9. Then this is the power rule. 9 comes in front. Logarithm of y plus 9 logarithm of z. So really, exponent here was 1. So if you want to write, insist having to see the 1 here, we could go straight from here to here, and that's what is expected in calculus, that you do it in a single sweep. So logarithm of y plus 9 logarithm of z. That was quick. Next, what if you have a ratio z over x7? So logarithm of z over x7. Again, we understand this is in base 10. Let's be quick here. Numerator, I have just z. Denominator, I have to subtract. And 7 comes in front of logarithm of x. So that's all there is to it. Important thing is to avoid a very common mistake. I even hesitate to write this thing because as if I'm encouraging to make that mistake. The student sometimes think this minus is this plus is on this side. So that's a very common mistake in college algebra. The student thinks that if you have a function, you apply it to a sum of two numbers that is same as that function applied to the first plus to the second. Why does a student make this mistake? Because this notation unfortunately looks like multiplication, but this is really a function notation. It's f at n plus n. It's not f times n plus n. You should just notice that from the context what is meant here. So that's an issue of notation. Unfortunately, you have no choice but to get used to it. Here's my remedy for this thing. Think about this thing. F of m plus n is f of m, f of n. They are not the same. So let's see. Can we avoid that? So what was it again? Students going to make what mistake? The student's going to think that logarithm of m plus n is logarithm of m plus logarithm of n. Why for this mistake? Because the student thinks that logarithm is a number that we are multiplying with the sum of these two numbers. Logarithm is not a number, it's a name of a function that you're applying to the sum of two things. It's a far cry from applying it to the first and the second. So we don't have that either. Let's hope that that mistake is avoided. So where does this mistake come up? In the third version, that's perhaps the more complicated of these things. 3, let me see if I can remember. 3. So the question is, how do you simplify logarithm of was it cube root of all of the expression or just the, yes, x plus 8 squared divided by x to power of 5. Let me write this thing a better handwriting. Okay, let's go through this step by step, see what happens. First of all, that root can be written as a power. Cube root means what? Power 1/3. Power here is how we deal with the power. The exponent comes in front of the expression that you have. So it's going to be 1/3 of logarithm of x plus 8 squared over x to power of 5. Okay, so 1/3 came in front. Next, we have a fraction here, and a fraction goes by the rules of fraction, which is this: logarithm of numerator minus logarithm of denominator. So here we are going to write 1/3 of. This 1/3 applies to everybody, so we need a parenthesis. Logarithm of numerator minus logarithm of denominator. Okay, when do we know to stop? How far are we supposed to go? You see, in all of these problems says each logarithm should involve only one variable and should not have any exponents. So we have to go as far as it takes. This is not the final answer because it has an exponent. By rule of exponent, these things are going to come in front. 1/3 of 2 logarithm of x plus 8 minus 5 logarithm of x. Question: can I do anything to this? Can I write it as logarithm of x plus logarithm of 8? Logarithm of x plus logarithm of 8. Is that right? Well, no. Sometimes they call that freshman dream, that all functions behave this way. No, almost none of them do. Can anything be done? Well, yes, wait until calculus 2, and there's going to be a 2-week lecture that's going to tell you what you can do. Right now, you can do nothing. So, final simplification, we just write it as 1 multiple logarithm of x plus 8 minus 5/3 of logarithm of x. So let's write the original expression so that we see what happened. We had logarithm of cube root of x plus 8 squared over x to power of 5. You notice that this root is here in the denominator, the exponents are in these numerators. What was in numerator of fraction is added, whatever is in denominator of fraction is subtracted, and we don't do anything to this right now. We just wait until calculus 2, Taylor series expansion, a hefty topic there. They tell you what you could do to this. Okay, so that was type 3. Type 1, type 2, and type 3, just small complication. We are applying the rules of logarithm in order. We created a combo rule for the simple cases. Exponents comes in front, items in numerator added, items in denominator subtracted, and we can quickly do this problem. The title of this thing is expanding. So sometimes you take a logarithmic expression, you want to take it to its break it into pieces. And in our next lecture, perhaps we are going to take a look at how do we collect all the pieces and how do you put the Humpty Dumpty back together into a single expression. Okay, so that was application of rules of logarithm. And good luck. God bless until the next.